Hello, and welcome to episode 2 of Into the Terminal, where today we're going to be talking about file permissions. So let's jump right in, shall we? All right, so what we're looking at here is a Red Hat Enterprise Linux box, and we're going to take a look at the file permissions on a file. So we're going to use ls-l to get a long listing of some content. Let's say user bin. And what we're looking at is the first section of this long listing output. And that's going to tell us the file type and then the permissions for users, groups, and others. It's going to tell us the number of links, which is inconsequential for today, and the user owner and group owner, size, date of last modification, and then the file name. I've taken the liberty of grabbing a file listing and putting it into a temporary file for us to take a closer look at. All right, so just deconstructing this one more time and concentrating on the permissions. So this is the type. So a dash means it's a regular file, D, directory, L, symbolic link, and there's a few others. This next section is the user permissions, right? This corresponds with the permissions granted to the user who owns this file. The next field is the group permissions. So if you're not the user that owns the file, but you are a member of the group that owns the file, these are the permissions that would apply to you. And the last field is called the others field. So this is if you're not the user, nor in the group that owns the file, then you're considered an other to the file, and these are the permissions that you receive. All right, looking at these three sets of permissions, I can see that the user owner of the file, which in this case is the root user, they have read and write permissions, but the third permission that's possible to have is disabled. The group that owns the file, which is the root group, gets read-only permissions, no write, no execute. And others also have read permissions, but no write and no execute. So let's take a look at how we might change that. So I was looking at the Etsy Red Hat release file. Let's pull up a listing here. Actually, let me clear my screen first. So if I decided that members of the root group, the group owner of this file, should also have write permission, then I could use the change mode or chmod command to say that the group owner should gain write permission on this file. And if we now look at the permissions, we can see that the group owner has write. If we decide that the user owner should have execute permissions, user owner gains execute. And if we look at the result, the user owner field now incorporates the execute permission. And if we were to decide that others should have no permissions, well, they already don't have write or execute, so I want to take away the read permission. So what we're looking at with chmod is a method of permission changing called symbolic notation, where we talk about the person that we want to change and what we want to change about them. So if I wanted to make some combinations, I can. So for example, if I wanted to reset the permissions back to what they were originally, I could chmod. The user should lose execute. The group should lose write, and others should green read. Right? So we can express through a series of symbols how we would like to change the permissions such that the permissions on the file are set to what we want. And I see a shout out from the Eighth Doctor there in chat. Hey, Eighth Doctor. As always, if you're interested in asking questions or you have a comment, please post in chat. We do pay attention to that. All right. So that's some basic permission changes. Um, One last thing I want to get into in our first little bit here is if we want to change the group owner of a file. Because right now, this file is owned by root and the root group. And in fact, I don't want to mess with this file because it's a system-wide configuration file. Let me make one real quick. I'm going to create a file here in this directory. Oops. Oh, no, hold on. Man, it's been a long day. Try that touch again. All right. So I've created this directory called students. And you'll recall from an earlier episode where we talked about managing users and groups that we had a user named Tony and a group named student. And I've created this shared directory for them to put their files and share them with each other. But currently, this file that I've created here, which should be available to other people in the student group, is only available or is read write for the owner root, but read only for the group and read only for others. So there's two things I need to do. One is I need to update the permissions so that I can give some additional permission to the group. And then the other thing I need to do is I need to change the group owner of the file with chgrp. So now people who belong to the student group are able to both read and write to this file because I changed the permissions to permit that. And then I also changed the group owner so that I could permit that as well. All right, looking at the chat, I see Eighth Doctor has some commentary there. Um, yes, there are more things in the uh, than what you can see with LS that you can mess with in permissions. Specifically, I think you're talking about file access control lists, but we're not going to get into that this episode, maybe a follow on episode. And yes, it did use a bunch of colons and stuff. All right, so the commands for that one, just so you're satisfy your curiosity, Eighth Doctor, is set FACL or set FACL and um, get FACL, get FACL. Those are the two commands they use for interacting with that. And that's an additional layer outside of normal Unix and Linux file permissions. All right, so that's our brief overview of permissions. So let's go ahead and jump into a little bit deeper look here. All right. So one of the other ways that you'll see people change permissions is octal notation for permissions. So prior to now, we've been talking about using symbolic notation where we talk about who we want to change and how we want to change them in order to make changes to the permissions. But it turns out that every permission has some value. So I'm going to go back into my little whiteboard file here. And it turns out that when we're looking at permissions, read is worth 4 points, write is worth 2 points, and execute is worth 1 point. So if we were to look at the exemplar up here of the Etsy Red Hat release files permissions, we could say that the permissions on this file accumulate to 6 points for the user, 4 points for the group owner, and 4 points for others. And if we were to use that in a command, let me go back to look at my data file here. So if I was to set the permissions on this data file to 644, What I'm saying is I don't care what the permissions were. I want the user owner to have a total of 6 points, right? A read and a write. I want the group owner to have read permission, and I want the others to have read permission. Right? So setting the permissions with octal value is a way of explicitly setting permissions. Turns out you could do this too with symbolic notation. So if I wanted to go back, I could say something like chmod user equals right, group equals read, other equal read. Right, so you can also set an explicit set of permissions. Oops, I meant read right there. An explicit set of permissions with symbolic as well. It's just a lot more typing than 644, right? So I reverted us back to where we were initially. All right, so I mentioned that I created this directory, uh, data student, and I created this file here for students to share back and forth. But notice that it's not owned by a student. So my users were in the student directory, Tony, and another one named Jill. They can come in here and they can see the file. And because they belong to the student group, they can do something like edit it, which is writing changes to it. Maybe Tony adds a some shell scripting to it. And if we wanted to, uh, we could execute this as a command, but we need to add the execute permission to it. So as Tony, maybe I say I want to add all people an execute permission on this file. But this isn't going to work because it turns out that only the owner of a file may change the permissions of the file. So while Tony is given the rights to make changes to the file, because he's not the owner, he can't manipulate other metadata about the file like its permissions. So I'm going to leave my Tony session. And what I'm going to do is I'm going to change the owner of this file using the chown command to change the owner. And I'm going to change the owner of this file to Tony. Right? So now that Tony is the owner, he gets covered under the first set of the permissions, right? The user owner permissions. Um, because Tony is covered under the user owner permissions, we stop looking for any other permissions if Tony is interacting with this file. If you're another member of the student group, then you would be covered under the group permissions. And if you are neither Tony nor a member of the student group, you get the others permissions. All right, so let me resume my session of Tony. If I don't go into a file. All right, there we go. And I want to add all people get the execute permission. All right, so we can see that the owner of the file got the execute permission. The group owner of the file now has execute permission, and others also got the execute permission. And what this means is that Tony can now execute this as though it were a command. Right? It actually executes the contents of that shell script, which is a series of echoes which print some statements to the screen. All right. Let me add one more user to my setup here. Right, so Frank is new to the system. He is not a member of the student group, right? I can let's look at groups and see that he does not belong to anything like student. He can go into this data directory for the student group, and he can see this file. But Frank is not the Tony user. Frank is not a member of the student group, which means Frank's permissions are others: read and execute. So if Frank wants to run this command, works fine. He has execute permission. If Frank wants to take a look at the contents of this file, he can see the contents because he has read permission. But if Frank tries to edit the file, notice that the file is opened up read only, right? Because Frank doesn't have write permissions. And if Frank comes in here and makes a change, I get the warning that it was a read only file. And if I try to write my changes, can't do it. If I try to force write the changes, can't do it because Frank, who is an other to the file, there we go. Frank, who is an other to the file, does not have the write permission, which says he can't make changes to the contents of the file. Now, if Frank wanted to, he could copy this to temp. Right? He can make a copy of that file and put it somewhere where he's allowed to place file contents because he has read permission. Read permission is what he needs to take a look at the contents and duplicate it. And then we had to put it somewhere else because if we look at the uh, data student directory, let me make this a little bit clearer. If we look at the data student directory, Frank doesn't have permissions to put files here, right? If you're the user owner of this directory, which is root, you have read, write, and execute. So you can look at the contents of the directory. You can add or delete files from the directory. You can go into the directory. If you are group owner root, you can look at the contents of the directory and go into the directory, but you can't add or delete files. And same thing for others. So Frank, as an other to this file, cannot add or remove files, right? I can show you that that's the case. Just do a touch. Not allowed. In order to put a file in a directory, you need to have write permission on that directory. Now we've been manipulating the files in this directory and the permissions on the files. Turns out permissions and changing permissions works the same way on a directory. So if I wanted to go out and make sure that student group could also put files in this directory I created for them, I can group it. Right, so now it's owned by the student group, and if I want the people in the student group to be able to put their own files there, I can chmod and add the write permission for them. Right, so now people who are root or the student group have read, write, and execute permission on that directory. And I see that Eric is here, and he says that he ran away. Um, Maybe we'll see him tomorrow on episode 3 of Into the Terminal, where we'll be talking about managing software packages with the DNF command. All right, so if you guys have questions, now is the time to stick them in the chat. Otherwise, I'm going to pivot and talk some about special permissions. And everyone's been quiet because they all want to know about the special permissions. All right, so there are 3 special permissions besides read, write, and execute. They are SUID, GID, and one called sticky, which technically is called STVX. And just like read, write, and execute, these also have octal value. So SUID is worth 4, GID is worth 2, and sticky is worth 1. And so just like our user group and other permissions, we could count up the points for these permissions and assign a numeric value. So we could do something like 4, 6, 4, 4. So that first permission in this 4-digit octal expression is the specials. So because I have 4 points, that means that I'm granting SUID on this file. 6 points for the user owner would be read and write. 4 points for the group owner would be read only. 4 points for the others would also be read only. So we could also do this with symbolic notation. So let me show you some examples of these, and then we can talk about how to set it with symbolic. All right, so I'm looking at some executables here in user sbin. Oh, and here's one right here called user helper. Okay, so let's just take a quick look at that. So what you'll notice about user helper, one is that with the colorized listing output that we use by default on Red Hat Enterprise Linux and the Bash shell, it is highlighted in red. Highlighted in red tells me that it is an SUID'd program. And if we look at the permissions, we can see the SUID sticking there, just hanging out in the user field in the execute place. So I can look at this file and say, okay, the user owner has read, write, and execute. The group owner has execute only, and the others has execute only. And the SUID permission has been set on this file. So if I was going to express that with chmod, I would say that's a 4711, right? SUID, read, write, and execute for the user owner, execute only for group, execute only for others. All right, what SUID does when it's placed on a file is when you execute this command, you temporarily switch your user ID or SUID to be the owner of the file. So if you're a regular person like Fred or Tony or Jill, when you run user helper, you temporarily, during the execution of that command, become root. And then when user helper completes, you go back to being yourself again. So you temporarily switch your user ID or set your user ID to something different. All right, let me see if there's one with SGID in here too. I know I've seen some around. There, we're going to do these things a little bit different. How about that, rep, um, yes. How about dash or W and S? All right, so I just see some SUIDs. Let's check in. Well, you know what? Let's just set it. I don't have to keep finding it. So I'm going to do a chmod 2775 on our data student directory. Actually, before I do this, let me show you what data student looks like again. So this is what it looks like before I set the SGID permission. And this is what it looks like after I set the SGID permission. All right, when SGID is set on a file, or I should say on an executable file, when you execute that command, you temporarily switch your group ID to be the same as the group ID that owns that command. But we didn't set SGID on a file, we set SGID on a directory. And what it means is when you create files in this directory, the group owner of files created in this directory are automatically set to the same as the group owner of the directory. So because the student group owns the data student directory, files created within it are automatically owned by the student group. So this is how we do shared directories so that we can put people in a group, we can create a file space for them, and then when they put files in that specific directory, they automatically get owned with the right group to allow collaboration between the users in that group. All right, eighth doctor asks about inheritance. Well, let's just see, shall we? Let's make a directory in data student called subdir. So you'll notice that the subdir there automatically got created with the student group owner, and you can see that the SGID permission was passed to it as well. And so people who are members of the student group can access data student, and then if they create additional sublayers of directories, they'll be able to interact with those as well, thanks to the SGID permissions. All right. Eighth Doctor asked, does that mean you can execute directories? So execute works a little bit different on files versus directories. So if execute is on a file, it means that you can run that file, right? So if the file is full of binary, it gets loaded into memory and executed. If the file contains a shell script, then we execute the shell and then load the interpreted language into it and execute it. So essentially, execute on a file means you can run a command. On a directory, execute means something slightly different. It means that you have access to the directory. So if I was to remove execute on data student, right? So notice that nobody has execute. Also notice that the SGID permission has become capitalized. It turns out that because SGID occupies the same field as group execute, the capitalization of that S tells me whether execute is on or off. So by looking and seeing a capital S, I can see that SGID is present, but execute for that group is not present. Okay, let me go back to being Tony, and I'm going to go into data student, except I can't. Because without the execute permission on that directory, people are not granted access to the directory. Now, because Tony has read access, he can still list the contents of the directory. Notice I had to do something weird with the ls command. I had to escape it because without it, I get some error messages because the ls command is actually an ls dash dash color. And ls dash dash color looks at metadata of files to see things like, is it executable? Is it a symbolic link? Does it have a different type of file? And based off of those metadata parameters, it will colorize the listing of the contents. But without execute, I can't access the directory. In order to look at those files' metadata, to see that additional information about them to colorize the ls output. So that's why I have to use non-aliased ls, right? And that works fine because it just is looking at the directory listing stored in the directory file. It's not then trying to access those files to get a little bit more metadata about them in order to colorize the output. All right, you said earlier that SUID triggers a user change on execute. It sounds like something similar happens here. It's more that when files are placed in a directory with SGID, we automatically set the group owner to be identical to that of the directory. So it's not really a set GID, it's more of a change GID, but only within the context of this directory structure. If I went in my home directory and created a file which is not an SGID directory, it would get my normal file ownerships by default. All right, the last special permission I mentioned was called sticky, and we see that as well on the system. And mostly we see it in places like temporary directories. Right, and sticky is special in many ways. One is it has a nickname, whereas SUID and SGID don't have nicknames. Right, its actual name is STVX, which is kind of hard to pronounce, so we nicknamed it sticky. But that's also something to do with how it operates. So you'll recall from earlier, um, I said that if you have write permission on a directory, you can both add and remove files. So if we were looking at a world writable directory like temp, one user could put a file into temp, but another user could take the file out of temp with remove or move. So by adding this sticky permission, it says that only the owner of a file may delete it from this directory. Right. So if I am Tony, right, I can create a file in temp, but if I am another user on the system, I can create my own file in temp. Right, I have write permission, so I can do that. Right. So there's the Frank file I just put into temp. But with the sticky permission, I can only remove my own stuff. So I can remove the Frank file, it's Frank file, just fine. But if, as Frank, I try to remove Tony's files from temp, not allowed. I can only delete my own stuff. All right, see, Eighth Doctor asks about SGID on files. Does it do the same thing as SUID? It operates very similarly. So SUID on an executable file, when the file is executed, will temporarily change the user's ID to be the same as the file's owner. So with SGID on an executable file, um, when someone runs it, they become the group that's identical to the group that owns the file. But only during the execution of the command. After the execution is completed, they go back to the normal ownerships and groups. You can set SUID and SGID on non-executables. So let's see here. Oh, let me go back to being Tony real quick. All right, so I could do a chmod 6, 6, 4 on the Tony file. Right, so it now has SUID and SGID, but when someone executes this file, or actually we don't have execute permission, but it's also not a binary file. So if it was a shell script or something, the SUID and SGID wouldn't actually change their ID mappings. And that's a function of how SUID and SGID works. You don't want somebody to be able to just write a simple shell script and be able to do something like become root by running a shell script, right? compiled binary is what gets that. Also, on other Unixes, putting the sticky permission on files does things, but on Linux, sticky permission only does things on a directory. Makes it so the write permission only applies to someone's own files. Um, on other Unixes, like old Solaris and things like that, sticky permission would mean that the file was unswappable when loaded into memory. So again, it would be applied to compiled binary executables, and it would stick in memory in addition to being stick in a directory. All right, well, that's a lot deeper than I expected to go on file permissions. So last call for questions, and we're at the end of our time together. All right. Well, again, remember that during the first month of Into the Terminal, we'll be doing 2 episodes a day, one in the East Coast morning, another in the East Coast evening, and excuse me, tomorrow's episode is on package management. So we'll be going through the DNF command and installing, removing, updating packages. So join us tomorrow, either the morning or the evening session for package management. Good day, everyone.